This is problem 2 in section 5.1. So here we were told that we have a 20 kilogram mass attached to a spring, and then we know that the frequency of simple harmonic or simple motion is 2 over pi cycles per second. And the question is, what is the spring constant, K? Well, you see, I have a couple of equations here that are going to be of use to us. So the frequency is omega over 2 pi. So omega over 2 pi is supposed to be, according to them, 2 over pi. And so I can solve here for omega, multiply times 2 pi on both sides. And I get that omega is equal to 4. Well, now with omega, I have m, because I have that m is 20 kilograms. I have omega, then I can find k. So k is equal to omega squared times the mass squared. And the mass is here 20. Sorry, not times the mass squared, but times the mass. And so I get that k is equal to 4 squared times 20. And that gives me 320. So that's the answer to part 1, where I'm finding k. That's k. Now once I know k, that's set, and I can find then the frequency of simple motion if the mass was 80 kilograms. Well, I know that omega, this is for part B, again is omega squared is k over m. And in this case, I would have that that's 320 divided by 80. And that's the same as 4, and so I get that omega squared is 4. And then omega is 2. Now, recall that this should be plus or minus 2, but in this case, we are only concerned with omegas that are positive. So now I can get the frequency, because the frequency then is omega, which is 2 over 2 pi, or 1 over pi. And that's the frequency of simple motion if we'd replace the mass with an 80 kilogram mass.